Good evening, everybody. We're going to be talking about rotations, and we're talking about the fact that rotations are actually turning figures in certain directions. There's two directions that you can turn figures, and we're going to discuss one of those this evening. At the end of tonight, we're hoping that you'll be able to draw the rotation of a given figure on a coordinate plane and determine the properties preserved. Remember, properties preserved means what's going to be kept the same about the figures. We can go ahead and turn figures in two different ways, and that's what rotations are. We can turn them in a clockwise rotation or a counterclockwise rotation. Clockwise just means in the same direction of a clock or to the right. Counterclockwise, well, let me just write right. There we go. Counterclockwise means we're going to go in the opposite direction of a clock or to the left. So let's take a look at this little diagram over here. I have a watering can, and it starts here at A, moves to B, and then moves to C. What direction are we going to? We're going to the right, which means it's a clockwise rotation, and that's what we're going to be talking about this evening. In a rotation, an object is turned, and that's what we mentioned. Tonight we're going to focus on rotating a figure 90 degrees clockwise about the origin. Well, that's a lot to take in one night. So let's take a look and break down this saying. First of all, it says 90 degrees clockwise. Well, you already know that clockwise means to move to the right. But what does the 90 degrees mean? Well, let's take a look at this diagram down here, our coordinate plane with points M and M prime. Notice M is here at -2, 3, and its image, M prime, after a rotation of 90 degrees clockwise about the origin, is 3, 2. Where do we get that terminology clockwise about the origin? Well, you know the origin is point 0, 0. And right down here on our coordinate grid is 0, 0. Notice point M and M prime. If I were to go ahead and connect M to the origin, and then the origin back to M prime, notice the distance from M to the origin and M prime to the origin is the same. Also notice this, moving in the direction to the right, which is clockwise rotation, I am actually creating a 90-degree angle when I pivot around that origin. And that's why it's called a 90 degrees clockwise rotation about the origin, because when I pivot around the point 0, 0 from point M to M prime in a clockwise rotation, I'm creating that 90-degree angle if I were to connect those points to the origin. Now let's take a look at how I can create a rule based on how I'm moving my points. If I start up here at point M, which is -2, 3, and my image after a rotation of 90 degrees clockwise, and I'm just going to write that here, is M prime, which is 3, 2. First of all, notice something about the numbers. The number here for the X coordinate seems to start with a -2. Notice over here, though, on the image, that 2 isn't in the X spot anymore. It kind of shows up where the Y coordinate would be. And notice here, an M, my original figure, my Y coordinate is 3. Notice where it's located on M prime. It becomes the X coordinate. That establishes the first step of my rule. The first step is that our XY will become, or will reverse itself and become Y, X. That is the first thing I am going to do with my points or my coordinates. I'm going to switch their order. So XY will become YX. But then notice here, I started off with a -2 and it ended up a +2. Well, that's going to be the second part of my rule. How do I remember how to switch the sign on a coordinate? Well, because this is a 90 degrees clockwise rotation and I'm moving to the right, notice my arrow is pointing to the X coordinate here after I've switched them. So that means I will change the sign on that coordinate. Let's go ahead and look down here at the rule that's drawn for us. We already talked about the fact that XY first reverses itself and becomes Y, X. Then we know we have a rotation 90 degrees clockwise, so it goes to the right. So we go ahead and change the sign on that X coordinate. Remember, this right here, this negative, doesn't mean the coordinate's going to be negative. It means we are going to change the sign. If I can remember how to spell change the sign on the x coordinate. Woo, let's hope we remember that. Draw your arrow, and you always will. Let's apply it now to a figure. Bam, here we go. Let's try using our rule on this figure. Okay, let's look at this figure we have. We have quadrilateral M, N, O, and P. First thing I'm going to do is I'm going to start over here, and I'm going to go ahead and I'm going to put in my coordinates of M. If I look at M down here, I notice that M is located at point -7, comma, -9. I'm going to go ahead and write that in over here, -7, -9. Now, if I apply the rule that I established on the previous slide, xy becomes y negative x, first thing I have to do is switch the order of my coordinates. So let's go ahead and do that. Because xy becomes yx, I am now going to write the -9 first, and then the -7. Now remember, there is a second part to my rule, and the second part to my rule is that I then have to change the sign, if I'm moving to the right or clockwise, on that -7. So that -7 becomes a +7. So let's go ahead and look at M prime and where it should be located on my coordinate plane. If I know my figure is going to be moving to the right, sorry about that, I'm recording at school as you can tell. If my figure is moving to the right, it should end up in quadrant number 2. Would you agree? Let's double check and plot point M prime to make sure that is where it's located. Plot M prime at -9, +7. Here it is. This would be M prime. And look, it is in quadrant 2. So far, my rule is following the direction, which is to the right, which is where it should be in quadrant 2. Let's now look at point N. Point N is located at -9, comma, -3. I'm going to go ahead and write that in over here, -9, -3. First thing I have to do, according to my rule, is switch the order of xy and make it at yx. So -9, comma, -3 first starts as -3, -9. Now, because I'm moving my rotation 90 degrees to the right, I have to change the sign on that 9 to make it a +9. So let's go ahead and graph that and make sure that one is in the second quadrant. I'm at -3 all the way up here to 9, and that is point N prime. Now let's look at O. O is located at -2, comma, -3. Let's write that in over here, -2, -3. Remember, our first step is to switch the order from xy to yx. So let's go ahead and write my -3 first, then my -2. I am moving this in a 90 degrees clockwise rotation. It's going to the right, so that means I changed the sign on the 2. So my new point is at -3, comma 2, and that will be O prime. Finally, let's look at P. P is located at -4, comma, -9. I'm going to go ahead and write that in over here, -4, -9. I start my rule by reversing my x and y coordinate, so it now becomes -9, -4. And because I'm rotating 90 degrees to the right, I change the sign on that -4 to a +4. So -9, 4 becomes my final, sorry about that, point, which is P prime. Now bear with me, I am going to actually, I don't know where that dot just went. Let's put that back in. Now let's go ahead and connect those lines to view what this will look like. Now don't follow my example. please use a ruler, because why wouldn't we want to make some straight, beautiful lines? I can't even believe my line is this straight without a ruler. It's like a miracle here happening right here. You see it? See it? Oh, that's a beautiful line. Okay, let's take a look at this figure. Did it end up where we thought it was going to end up? It did. Did we follow the directions? Ooh, did we? It says label the coordinates of each point on the new figure. Well, let's go ahead and do that. M prime is at -9, 7. N prime is at -3, 9. O prime is at -3, oops, sorry about that, 2. And finally, P prime is at -9, 4. Beautiful. Now we followed all the directions. We have it labeled correctly. It's in quadrant 2, which is exactly where we expected it to be, and it was turned 90 degrees clockwise about the origin. How would we check to make sure it is a 90-degree rotation? Well, once again, we have to look at our origin, which is 0, 0. Let's go ahead and connect O to that point and O prime to our origin. Notice our distances are the same from the origin to point O and from the origin to point O prime. Notice what kind of an angle we have definitely produced here. It looks like a 90-degree angle. So does it match everything we've talked about so far? It's a 90 degrees clockwise going to the right, rotation about the origin, which means it's pivoting about the origin. Excellent job. So these are the properties that are preserved under rotations. Remember, preserve just means what do we keep? What do we keep about those figures? First of all, we keep distance. The distance is preserved, which means the lengths of the segments are the same. Remember, line segments, I'm going to write this, and I'm just going to abbreviate, map to line segments, which means they're going to have the same measurement. Angle measures remain the same, so angles map to angles because these are rigid motions. Perimeter stays the same. Because line segments map to line segments and they have to stay the same, the perimeter or the distance around the object also has to stay the same. The area or the amount of space taken up by the figure has to remain the same because my angles are the same and my line segments are the same. Finally, orientation stays the same. Remember, that's letter ordering. If we were to look up here at our diagram and we start at letter A on our original figure, notice it goes from A to B to C to A. Notice in my image, it goes from A prime to B prime to C prime, and finally back to A prime. So because they match, guess what? Orientation stays the same. I hope you learned a lot tonight. Tomorrow you're going to come into class and you're going to work on some activities on your own, and we will see you tomorrow. Have a great night. See ya.